This series, we're going to be learning what artificial neural networks are and how to create them from scratch in Python. But if you know any programming language, then you can pretty much follow along because this will be making it so simple and so basically that it's pretty much doable in any language. So, who is this series for? It's mainly for people that want to learn about neural networks and are beginners in the area of artificial intelligence. And it's also for people that are intermediate in knowledge of neural networks and just want to build upon their skills and foundations of neural networks. So let's move on to actually discovering what an actual neural network is. An actual neural network is basically just a network of neurons, simply put. And each neuron is just basically a number. So a neuron could be 1, it could be 0, it could be 2. So let's kind of demonstrate the idea of input and output. So basically in a neural network, you basically feed it some sort of input and it tries to get some sort of output basically based on how you trained it and what you want it to really find out. So say I input this picture of a single digit number. I want it to basically guess what single digit number is contained inside of this image. So the single digit numbers are listed down here. So there's going to be 10 basically output neurons. And if our neural network works properly, it will basically make 7 the output neuron. And so how would we actually input an image into a neural network? And the way we would do that is basically by first breaking it down into pixels. So if this image is 28 by 28 pixels, basically there's going to be 784 pixels. And if you also convert the image into black and white like I did, you can represent each pixel as a value between 0 and 1 or 0 and 1. So if the pixel is white, it's going to be 1, and if it's black, it's going to be 0. And if it's in between, the darker the pixel is, the closer it's to 0, and the lighter it is, it's closer to 1. So say this gray pixel over here that's pretty light, it's going to be pretty close to 1. But unlike that, this dark pixel over here would be closer to 0. So next thing we want to know is basically what's happening when we input this to get this value, basically make this bright. Basically, when we input something like this image, basically going to be 784 input neurons, but obviously I didn't represent it here to keep it simple. It's going to basically give each one of these output neurons a value. And the greater the value, the more confident the neural network is in that value being the correct answer. So say I input this image and it outputs like 0, 0, 0, 0, 0, 0 here, but then 1 over here, and then 0.1, 0.1. This is the greatest value, right? Because this would be 1, and this is 0.1, 0.1. This is all 0. So those are all very low values. And so because this is 1, and it's the greatest value, that means that our neural network is most confident in this neuron being the correct answer. And indeed it is, because the image does represent is 7. And basically our goal in a neural network is basically to make all the other outputs as low as possible and making this one the highest value. Now, how do we get these values? When we input a neuron, so let's just say one of the neurons is equal to 1, and we input that 1, basically you have to find out all the neurons that go to that specific output neuron you're trying to find the total of. So say this output neuron, you can see there's 3 connections, basically 1 from each of the neurons. And say each of these neurons had a value of 1, you would basically add all 3 of them up, and that would be the sum of this output neuron. So in reality, if we are going to have 784 of these input neurons, so you would add each of their values up, and it would equal this output neuron's value. So say they were 1, all of them, then this would be 784. And that's just a made up number. That's obviously not going to be true for an image like this. Otherwise it would just be a huge white image. But as you can see, if it all was just 1, or if it was the same value, it would just output the same value for each of these neurons, right? So we don't want that. We want to basically change the values depending on what the input is. And the way we can do that is by using something called weights. And what weights basically are is they just tweak the output values. So they will make it so that these neurons will have really low values, and this one will have a really high one, and these will again have low values. And so let's look a little bit more in depth into weights. So where are weights? What are weights? Basically, there's a unique weight for each connection to an output neuron. So as you can see, there's 3 inputs neurons and 1 output neuron. There's an individual weight for each one of these input neurons. So this one's 3, this one's 2, this is 1. Now, how do you calculate this output? So what you would do, now you wouldn't just say it's 1 plus 0 plus 1, so that would be 2. Now you have to multiply this 1 times the weight. So the weight here is 3, so 1 times 3 is 3. 2 times 0 is 0, and 1 times 1 is 1. And you would add all 3 of those values, and that would be your output neuron value. So 3 plus 0 plus 1 is 4. And that would be good. So going back up here, now we have a little bit of understanding of a weight. Basically, when we have certain values as inputs, it basically tries to make these values as low as possible and make the correct one as high as possible. The next thing we want to learn is something called biases. Biases are like weights. They help to tweak your output to make your model basically more accurate and give you the right answer. So, but the difference in biases is that it's only 1 per output neuron. So there's only 1 output neuron here, so there's only 1 bias. And instead of multiplying, we're going to be adding the bias. So first, we have the same weights here, so we're going to get the same value for the output, so we're going to get 4. But in this case, we're going to add 2 because that's the bias of this output neuron. So 4 plus 2 is 6, and that's what we get here. So the last thing we want to cover in this basic introduction to neural networks is something called backpropagation. It's basically the concept of tweaking those weights and biases to get accurate results for our outputs. And that's basically just training our neural network, and that's really what makes our neural network functional, tweaking those weights and biases to get those accurate output results. And backpropagation might sound like a pretty complicated term, and it can be, but when we start coding it and getting more in depth into it, it will sound really simple in the way we do it. So that's it for this video. Next video, we'll actually be diving into coding part of our neural network and just like doing some basic things and basic understandings. So thanks for watching.